Good evening, everyone. Is my voice clear and audible?
Yes, sir.
Yes, sir.
Good. Fine, guys. So, in the last session, theoretically, we discussed several topics in the Kubernetes. We discussed about what is Helm charts in the Kubernetes, and we discussed about what is Prometheus and what is Grafana, and we also discussed about EFK stack in the Kubernetes. So theoretically we understood what is Helm chart, why we need to go for Helm charts, and what is Prometheus, what is the purpose of the Prometheus, what is the Grafana, why we need to go for Grafana, and what is EFK stack. Here, Helm charts we are going to use as package managers in the Kubernetes. So what is the meaning of a package manager? Package manager is nothing but that is a software which is used to install other softwares in the Kubernetes cluster. If you want to install any particular software in the Kubernetes cluster, then you can use Helm chart and you can install that software. So Prometheus is used for monitoring the cluster resources. How many nodes are running, how many pods are running, what is the status of the nodes. All that information Prometheus will collect from the Kubernetes cluster. And next we are having Grafana. Grafana is also a monitoring software. Grafana will provide the details in the visualization format. Prometheus will collect the data from the cluster, will give to the Grafana, and Grafana will present that data with the beautiful UI. Next one, EFK stack is available. EFK stack is the combination of three open source products. One is Elasticsearch, second one is Fluentd, third one is Kibana. This EFK stack is used to monitor the logs of the application. When the application is running in the production, there is a chance of getting a lot of issues. So when we get the issues, then we need to identify what is the root cause of those issues. So to identify the root cause of the issues, we can check the logs of the application. So in the real time, multiple pods will be available in the multiple worker nodes. So checking the logs of all the pods manually is very difficult. So that's why we need to centralize logs of our application. To centralize logs of the application, we are going to set up EFK stack platform. Okay, good guys. Now, so let me set up the Helm here. What is Helm and what is Helm chart? So we already understood the concept now. So let's see here what is Helm and how to install that Helm. Helm is a package manager which is used to install required softwares in the Kubernetes cluster. Helm will use charts to install the required packages. What is the meaning of the chart? Chart is nothing but collection of configuration YML files. So instead of we are writing the manifest YMLs in the Kubernetes, we can take the pre-configured YMLs as part of Helm chart. Okay. Now I want to install Helm charts. Okay. By using Helm chart, we can install Prometheus in the server and we can install Grafana also in the Kubernetes cluster. Now let me go for Helm installation. First in my cluster, I want to install Helm charts. Okay. So in order to install the Helm, let me execute these commands, guys. So by using these three commands, we can install Helm software in our Kubernetes cluster. I connected with my K8S host VM and I'm creating my Kubernetes control plane. So last Friday we had the last session. After Friday class, I have deleted my Kubernetes cluster and again I have started my cluster creation today. Okay. Once the Kubernetes cluster got created, now I am going to execute these three commands. Okay, these three commands are used to install Helm in the Kubernetes cluster. So once we install the Helm in the Kubernetes cluster, by using this Helm, we can install other required softwares in the Kubernetes cluster. So this is used to download that Helm software. And here we are giving all the permissions for the user on the Helm software. And we are executing the Helm software. Helm software we are installing by using shell script file. In order to execute the Helm, what are the commands are required? Those commands are already available in the shell script file. I'm just going to execute that shell script file. So once that shell script file got executed, we can check the Helm software is installed or not. Okay. So let's wait for the cluster to be created. Yeah. So meanwhile, I have given one task for you on the Friday. So did you guys completed that? I have given one task for you on the Friday to set up EFK stack in the Kubernetes cluster by using manifest YMLs. Did anyone try that?
Yes, sir. I tried using your GitHub repository. From there, I downloaded the YMLs.
So you tried setting up the EFK stack in your cluster. Is it
Yeah.
successful, guys?
Yeah, it's successful.
Successful. So you are able to set up the EFK stack in the Kubernetes cluster to monitor logs of the application.
Yeah.
How much time it took for you to do that, guys? How much time you spent?
Half an hour.
Within half an hour, you are able to complete the EFK stack setup.
Yeah.
Okay, good. So Akash has done that trial. Good job, Akash. Anyone else tried that task?
Sir,
Last Friday, I have given the task for you. Manikanta?
Yes, sir. I have tried, sir. I was able to see the log successful in the Grafana, sir.
Okay, you are able to see the logs successfully in the Grafana. Grafana is
Kibana. Sorry,
Kibana.
Kibana.
Sorry. Yeah, Kibana is a visualization tool where we can see the logs of the application.
But I was trying to understand the YMLs which you have written, sir. So
They
only
are very lengthy, sir. They are very
yes, sir.
lengthy.
Only 40% I was able to understand because whatever the class you taught, I was able to understand 40%, sir.
They are very lengthy, sir. Even I have taken that from the internet only.
Oh, okay, sir. In real time also, can we use, the same
YMLs? Yes, we can use the same YMLs.
If you can give the overview of the fluentd, it will be very
Sure,
helpful.
sir, definitely. Yeah. So right, guys, with this my cluster is ready. So you can verify the cluster resources. kubectl get nodes command. So it is going to tell you what are the worker nodes available in the cluster. So in my cluster there are 2 worker nodes available, and those worker nodes are in the running status from 2 minutes. So just now we have configured this worker nodes. kubectl get pods. Now you can check, are there any pods available in the cluster? No. Currently in my cluster, pods are not available. No resources found in the namespace. Now let me check the Helm. Is the Helm available in my cluster? No. Helm is not available in my cluster. In order to install the Helm, I have given 3 commands, guys. So let me copy these commands and execute one by one. I want to install Helm in the Kubernetes cluster. Okay. Yes, I have downloaded that by using curl command. Then next one, give some file permissions. Shell script file is available. Okay, so before giving that file also you can verify what is available there. ls-l. So you can check this. Get helm.sh file is downloaded. Okay, read write permission is available on this sh file. Execute permission is not available on the sh file. So I want to provide execute permission. So to change the file permissions in the Linux, we are going to use a command called chmod command. We used a command called chmod command. Once the file permission is provided, let me execute that shell script file, guys. So to execute the shell script file, we are using that sh command. Yes, with this, Helm is installed successfully. Then check Helm is working or not. Yes. So when I execute this command called Helm, then we are getting some output. So with this, Helm software is installed in the Kubernetes cluster. We can use that Helm software as a package manager. Okay. Now, so let me show you one simple example to say that this is a package manager. Let me check kubectl top nodes command. I'm executing top nodes command. So what is the meaning of top nodes command, guys? What is the meaning of top nodes command?
Metric data will be shown.
Yes, it will provide you the metrics, right? The metrics server will get the memory level details of the top nodes and top pods. When you execute top nodes and top pods, metric server will be available in order to provide the details. But currently, am I able to get the details or I am not able to get the details?
No, sir. HPA server is not available, sir.
Yes, not HPA. Metrics API is not available. So in my cluster, Metrics API is not available. So in Kubernetes cluster is available. In the Kubernetes cluster, Metrics server is not available. Metrics server is not available. Now I need to install the Metrics server. There are 2 ways we can install the Metrics server. Already in the HPA example, I have installed Metrics server. But at that time, how I installed Metrics server in the Kubernetes cluster, guys? Manually we installed by taking YML files. So in my GitHub account, I have given a lot of YML files. By executing those YML files, we are able to install the metric server in the Kubernetes cluster. So instead of we are writing those YML files, can we use package manager to install metric server? Can we use the Helm chart to install the metric server in the cluster? Come on, guys. So in my Kubernetes cluster currently, metric server is available or metric server is not available.
Not available, sir.
Currently
Not available.
Now
Yeah.
I want to install metric server in the cluster. In two ways we can do that, guys. Okay, so metric server is not available. So metric server is not available. So by executing these commands, I'm checking top pods command and top nodes command. Metrics API is not available. Now I want to install the metric API. In how many ways I can install the metrics API, metric server in the cluster? Two ways are there. One is, what is the first approach? One is execute manifest YML. Execute manifest YML. Second one, use Helm chart. Are you guys getting my point? There are two things available. One is you install the metric server by using manifest YML files. Or second one, you use a Helm chart in order to install that metric server in the Kubernetes cluster. Already we have practiced this. We have done with this process. We are done with this process. So do you remember when we executed manifest YML files to install the metric server? In the HPA example, we have installed metric server. At that time, we configured metric server in the cluster by using manifest YMLs. So today, I want to install the metric server by using Helm chart. Helm is a package manager which is used to install the required softwares in the Kubernetes cluster. Now, so I connected with my Kubernetes cluster. I installed Helm also. Before going to install these things by using Helm repo ls. So currently, is there any Helm repository available or Helm repository not available? Do we have anything in the Helm repository to install?
No, sir. No, sir.
Currently, we don't have anything to install in the Helm repository. So I need to add this metric server to the Helm repository. Then I need to install that. So first I am going to check, is there anything available in the Helm repository or not? So to check is there anything available in the Helm repository or not, I'm using Helm repo ls command. I'm using Helm repo ls command to check is there any repository available or not. Okay, so before you can install the chart, you need to add the server to the Helm repository. So this is the command I'm using, which is used to add the metric server to the Helm repository. Okay, metric server has been added to your repository. Now you check it, Helm repo ls command. So earlier when I execute a Helm repo ls command, it was giving some error. No repository is available to show. Now when I execute the Helm repo ls, the metric server is available in the Helm repository. Once this metric server is available in the Helm repository, you can install it. By using Helm upgrade command, metric server repository is available. So install the chart. Here we are adding the chart to the Helm repository. This is the official chart name for the metric server. We added that to the Helm repository. Now we are going to install that chart by using Helm upgrade command. Okay, let me execute this command. Metric server not available, installing now. That's it. So with this single command, we are able to install metric server in the Kubernetes cluster. Earlier we have executed several commands, several manifest YMLs in order to set up the metric server in the Kubernetes cluster. Okay, so we have taken 4 YML files or 5 YML files we have taken, and we have executed those 5 YML files. When you execute 5 YML files, then metric server got installed in the cluster. But what is the easiest way to set up the software in the cluster? By using Helm chart. Okay, I have seen Helm repository. Initially nothing is available. Then I added metric server to the Helm repository. Then I have installed the metric server by using this Helm upgrade command. So once it is done, once we have installed the metric server, let me check kubectl top pods. Now is metric server working or not? Earlier metric server was not working. Now we are able to see that metric server is working. So who installed metric server? How we installed metric server in the Kubernetes cluster now?
Help.
Helm chart.
Yes. So I have installed that metric server by using manifest YMLs, or I installed the metric server by using Helm chart. What is Helm chart now? What is Helm chart and what is Helm? Can you guys tell me?
Helm chart is used to register the.
What is Helm and what is Helm chart?
Helm is a tool where we can monitor.
Helm is a package manager which
Package
is used
manager.
to set up the required softwares in the Kubernetes cluster. So if you want to install any software in the cluster, in two ways we can do. One is directly download the manifest YMLs and execute it. Last time, do you remember when we are working with the HPA, we configured metric server in the cluster. At that time, we have taken the manifest YML files. With those manifest YML files, we have configured metric server. But today, again, I am installing the metric server in the cluster, but this time I'm not using manifest YMLs. I'm using Helm chart. Directly, the metric server Helm chart is available. We added that to the repository and we have upgraded that repository. Okay. So with this, we are able to install Helm chart. Now here metric server is installed in the Kubernetes cluster. So practically we are able to see kubectl top pods. It is giving the information related to that. Metric server pod is running. kubectl top nodes command is available. Earlier this command was not working. Now this command is working and it is giving the output for us. Okay, that means we are able to set up the metric server in the Kubernetes cluster by using Helm chart. I hope it is clear for all of you. I hope it is clear for you. Now, next one, how to set up Prometheus and Grafana. Okay, so we have seen Kubernetes monitoring, guys. Prometheus and Grafana, theoretically we have discussed it, right? They are used for monitoring. So what is the purpose of this monitoring? So in the Kubernetes cluster, lot of components will be available. Worker nodes will be available, pods will be available, services will be available, namespaces will be available. Lot of resources will be available in the Kubernetes cluster. We can monitor our Kubernetes cluster and the cluster components by using below softwares. What are those softwares? One is Prometheus. Okay, and the second one is Grafana. Prometheus and Grafana softwares are available. What is this Prometheus? As we discussed, it is an alerting toolkit. It will be available in the Kubernetes cluster and it will provide the metrics. It will provide the metrics to the Grafana software. Prometheus is an open source system monitoring and alerting toolkit. That Prometheus will collect and store the data as a time series. That means very frequently the Prometheus is going to collect the data from the cluster and it will provide the out of the box monitoring capabilities for the Kubernetes orchestration platform. So Kubernetes is called orchestration platform. In the Kubernetes platform, we are running lot of resources. We are creating lot of resources. When those many resources are running in the cluster, definitely monitoring is required. In order to do the monitoring of the cluster resources, we are going to use this Prometheus. Prometheus will connect with the cluster, will get the cluster data and will give that cluster data. That cluster data should be displayed in the beautiful user interface format. That's where Grafana software comes into picture. What is this Grafana? Grafana is an analysis and monitoring tool. Grafana is an analysis and monitoring tool. Grafana is a multi-platform open source analytics and interactive visualization application. Okay, Grafana is an analysis and monitoring tool. It provides visualization for the monitoring. It provides visualization for the monitoring. So like some kind of graphs will be provided. Okay, with user interface will be provided by the Grafana. It provides the charts, graphs and alerts for the web when connected to the supported data sources. So Grafana will allow you to understand the cluster resources and what is the memory they are occupying, how they are running. Okay, Grafana will connect with the Prometheus for the data source. Grafana and Prometheus will work together. Prometheus will collect the data from the cluster. Prometheus will give the data to the Grafana. Grafana will connect with the Prometheus, get the data and display the data in the visualization format. Okay, now, so here theoretically we understood in the last week only how to set up this Prometheus and Grafana in our Kubernetes cluster, how to deploy Grafana and Prometheus in the cluster. So again, two ways, using manifest YML files, using Helm charts. So now I am going to set up this Grafana and Prometheus in the cluster by using Helm chart. Okay, so install Prometheus and Grafana in the Kubernetes cluster by using Helm chart. Helm is a package manager which is used to install required packages in the Kubernetes cluster. Grafana and Prometheus I want to install in the Kubernetes cluster. So the first step, add the latest Helm repository in the Kubernetes. This is the first step. Okay, add Prometheus repository to the Helm. First we are going to update the latest repository, then Prometheus repository we are going to do, then update our Helm repository after adding the Prometheus. So once it is done, then install Prometheus. Once it is done, then install the Prometheus. Once Prometheus is installed, then we can check what all the pods are running. kubectl get pods command. Okay, so we should be able to see the pods running and we should be able to see the services which are running also. Get svc command. Okay, so by default, this Prometheus and Grafana will run by using service as cluster IP. Okay, initially they will run by default with the cluster IP. So for Prometheus, some pods will be created. For Grafana, some pods will be created. Those pods will be exposed by using cluster IP service. Cluster IP service nothing but within the cluster only we can access, outside the cluster we cannot access that. Okay, cluster IP means within the cluster only we can access, outside the cluster we cannot access that. Within the cluster only we can access, outside the cluster we cannot access. So then what we need to do in order to access the pods outside the cluster, we need to change the service type. So by default they will work with the service type as cluster IP. Now I need to change the service type to some load balancer. Look at this. What is the process to install? Prometheus and Grafana in the cluster by using Helm chart. So add the latest Helm repository in the Kubernetes. So first let me go and execute these commands. Okay, I got disconnected. Client loop out. Yeah. Now I connected with this. Yes, let me do the stable repository update. Stable has been added to the repositories. Then add the Prometheus community. The chat name is Prometheus community, guys. Helm charts are available. So take this Prometheus community repository and add it to our Helm repository. Okay. So Prometheus community has been added to our Helm repositories. Once it is done, let us go for Helm repo update. Okay. Let me go for Helm repo update. Successfully updated that chat Prometheus community. Update completed. Happy Helming. Once it is done, then let me install that Prometheus community. Before going to install Prometheus community by using Helm chart, let me check what all the pods available. kubectl get pods command. Currently only metric server pods are running. Prometheus Grafana pods are not available. Now let me execute it. Helm install Prometheus community. I'm going to use Helm install Prometheus community. Yes, it is taking time to install that Prometheus community by using Helm chart. With this Grafana and Prometheus, both softwares will be installed in the cluster.
Did we install the metric server?
Yes, it is already available, right? We already configured that. Yeah, now you can see Helm install. We have done the installation, stable installation, status deployed. So kubectl namespace, Prometheus stack has been installed and it is running. Now you can check it. Kubectl get pods command. So earlier when I see kubectl get pods command, only metric server pod is running. Now when I execute kubectl get pods command, Prometheus, Alert Manager, Kubernetes Prometheus, Stable Manager, Prometheus, Node Exporter, all these pods are created. Okay, now let me check the services also. kubectl get service. Now you can see Prometheus service is running and Grafana service is also running. Prometheus service is running, Grafana service is also running. That means by using this repository, we are installing the Prometheus community. So line number 1047 to add the Helm charts, Prometheus community to the Helm repository, and here Helm install. Whatever the Helm chart is available, Helm chart nothing but set of YML files. Helm chart nothing but set of YML files. We are installing that Helm chart. When we install that Helm chart, it installed Prometheus as well as Grafana. Prometheus and Grafana softwares installed as pods only, and those pods are exposed by using service. What is the default service it is taking? Everything is available as a cluster IP. If everything is available as a cluster IP, can we access them outside of the cluster? We cannot access them outside of the cluster.
Not.
Can we access them outside of the cluster? We cannot access them outside of the cluster.
Okay, noted.
We cannot access it.
We cannot access them outside of the cluster. Now I need to change the service type. Okay, this is service I created manually with the YML. This service I created by using Helm chart.
Helm charts.
This service I created manually by using our YML file. Have I created the service by using Helm chart?
Using
Helm
Helm
chart,
chart.
Helm chart.
Using Helm chart. If I create the service manually with our YML, I can edit that YML and I can apply the same YML again. Got my point? So if it is our YML file, I can go to that YML, I can change the service type and I can re-execute the same YML. Then the service will be changed. But we don't have any YML. Helm chart we use it directly and we have installed the Prometheus Grafana. Prometheus pods, Grafana pods are running and those pods are exposed by using service. And that service type is cluster IP. Cluster IP means only within the cluster we can access. Outside the cluster, we cannot access that. Outside the cluster, we cannot access that. Now, if I want to access these pods outside the cluster, I need to change the service type. Okay. Based on the name of the service, we can change the service type also. If I have YML, I can go to that YML, I can edit the YML and I can reapply that YML. So when there is no YML, how can you edit that? Okay. So I am going to give you the command which is used to edit the services directly. Okay. Edit the services directly. These are the commands. kubectl edit service name Prometheus. kubectl edit service name Grafana. So Prometheus service I will edit and I will change the service type to load balancer. I will change the service type to load balancer. Edit the Grafana service and change the service type to load balancer. Then save that. Then save and close that file. So these services got created by using Helm chart. Now I am going to edit them by using that service name. It is not our YML which is used to create the service. So it used Helm chart. Helm chart nothing but configuration files only. The thing is, instead of we are writing the manifest YMLs, we can use the Helm chart to take care of that. Helm chart will contain the manifest YMLs. Now let me go to this service and edit the service type. kubectl edit service, name of the service, which is Prometheus service. So when I edit, it is showing the YML which is used by the Helm chart. Now coming to the service type, port mapping, spec, cluster IP, ports available 9090, selector available, type. Yes, service type is available as cluster IP. Now let me change the service type to the load balancer. Okay, I'm just editing the Prometheus service with its service name, and I'm changing the service type from cluster IP to load balancer. Let me save it. So when you modify that, that service is edited. That means the service is updated. So what is the command I have used? kubectl edit the service, name of the service. So when you edit the service like this, it will open the YML which is used to create that service. Helm used one YML to create the service, right? When you edit the service, it will open the YML which it used to create that service. Now you can check the services available. Earlier everything is a cluster IP. Now you can see Prometheus service type is changed to load balancer. So earlier everything is a cluster IP. Now the service type is changed to load balancer. Similarly, I need to change the service type for the Grafana also. Now Prometheus service is running as a load balancer with the port number 9090. Let us go here, enable that port number in the security group inbound rules, guys. So let me go to this machine, edit the inbound rules, security.
Can we do the same for the YAML file we have created?
Yeah,
Just
if you have
edit.
YAML also, you can do the same thing.
So we no need to re-execute the YAML file, right?
YAML file, if you modify, you need to execute it. Here directly you are modifying the service, na? If you have a YAML file, once you change the YAML file, you need to reapply that, right? kubectl apply -f file. Then only service will be modified.
But sir, would it not create an issue when we are editing the cluster IP to directly to the load balancer?
Sir, this is for practice purpose I'm showing you. In the real time, we don't do like that.
Okay.
Yes, my Prometheus service is running. Its service type is load balancer and it is running on the port number 9090. Now you can go to EC2 here. In the EC2 dashboard, you can see one load balancer which is belongs to our Prometheus server, which is used for monitoring the data from the cluster. Okay, this is the load balancer of the Prometheus, created at 8:14, July 1st, 8:14. Yeah, UTC time zone 8:14. This is the DNS name. Copy this DNS name. The port number for the Prometheus, which is 9090. I have enabled that in the security group. Now you can see we are able to access Prometheus dashboard. So Prometheus is used for monitoring the cluster resources, guys. This Prometheus we have installed in the cluster by using Helm chart. Helm chart nothing but set of configuration YMLs, the manifest YMLs. So in the initial classes of the Kubernetes, we created pod manifest, service manifest, deployment manifest, etc. Okay. Now in the real time, when you want to install particular software in the cluster, instead of you are writing the manifest YML on your own, you can directly install that software by using package manager called Helm. So Helm provide the charts for you. One chart nothing but set of configuration files. So Prometheus chart I have executed. So Prometheus server got deployed in the cluster. Okay. Now similarly, I want to install Grafana. Okay. Grafana pods are running. Service type is available as cluster IP. Now I want to change the service type of the Grafana also to the load balancer. Okay. Go there and edit that. Stable Grafana service I'm editing. Its YML file is coming, which used by Helm chart to create this Grafana service. Now type is available as a cluster IP. Let me change the service type to load balancer. Service type is available as cluster IP. I'm changing the service type to load balancer. Now save it. Grafana service also edited. Now you can see Grafana service also will display as a load balancer. So earlier there was only one load balancer for the Prometheus service. Now we have two load balancers. One is for Grafana service, another one is for Prometheus. Prometheus will collect the data from the cluster, will give to the Grafana. Grafana will display the data in the visualization format. Graphical charts we can generate by using this Grafana. So Grafana load balancer is creating. Grafana is running on the port number 80 only. So that is the default port number. Prometheus is running default on the port number 9090. Let me take my Grafana DNS URL and let me access it. Grafana is running with another load balancer type. Yeah, this is the Grafana load balancer DNS. Go to security group. Inbound rule 80 is the port number. HTTP protocol we need to enable. Edit the inbound rules. Custom TCP 80 is already enabled. Save it. Grafana DNS URL I am accessing.
So Grafana and the Prometheus have the same port access 80 for the two applications.
Your voice is not audible, man.
I'm asking if the two applications will run on the same port 80.
Yes, they can run. Now see, Grafana is also loaded. So Prometheus server dashboard we are able to access, which is running in the cluster. We have executed the Prometheus by using Helm chart. Grafana also we install in the cluster by using Helm chart only. Okay, we are not writing any YML files to install Prometheus parts and Grafana parts. Ready-made Helm chart is available. By using Helm chart, we are able to install Prometheus and Grafana. Now, after editing this, I'm able to access the Grafana. The default login credentials for the Grafana, username will be admin and password will be prom operator. Okay, so you can check. What is the username for the Grafana? The default username for the Grafana is admin. The default password for the Grafana is prom operator. Click on login. So with this, I'm able to log in into Grafana server. So this Grafana will provide the data in the visualization format. Grafana will provide the data in the visualization format. Okay, but who will give the data to the Grafana? How Grafana will get this data to display?
Prometheus will provide data to Grafana.
Yes, Prometheus also running in the cluster. Grafana also running in the cluster. Prometheus server will collect the data from the cluster, will give to the Grafana. Grafana will provide the data in the visualization format with some charts. Okay, now go to dashboards. In the dashboards, you can see what all the resources are running. Okay, Alert Manager, etcd, Grafana, Kubernetes API server. So Kubernetes API server availability 100% is available. So here you have options to monitor the Kubernetes resources basically. Okay, go to the dashboard. Which resource that you want to monitor, you can check scheduler. So check the scheduler. Currently in the scheduler, any data is available. Currently in the scheduler, there is no data is available. Okay. Then go to API server. API server available 100%. There are no errors available in the API server. Currently, the API server is healthy. Currently, the API server is healthy. Kubernetes API server. Now, controller manager kubelet. Let's go for kubelet. So total 2 running kubelets available and a total 14 pods are running. In the 14 pods total, 25 containers are running, 60 volumes available, 60 volumes extra they need. So you can monitor. You can monitor any resource which is available in the cluster by using this Grafana. It will provide visualization to monitor the resources available in the cluster. So in the cluster, we installed Prometheus Grafana by using Helm charts. Prometheus will collect the data from the cluster and will give to Grafana. Grafana will display the data in the beautiful visualization format. Are you clear with my point? Now, so by using this Grafana dashboard, can you see all the resources which are available in the cluster and how they are working? Prometheus overview, Prometheus stats.
Sir, what do we understand out of this? I mean, what to check in this dashboard?
So now you can monitor all the resources. Suppose, for example, if you want to monitor Grafana, so no data is available in the Grafana.
Can you simulate a problem so that we can see how to resolve it in the dashboard?
Sorry, sir?
I'm asking if you could simulate a problem with any of the containers so that we can see how to resolve it in the dashboard. To see the problem. That example, like
yes.
what usually happens.
I'm not getting your question.
He is asking to create the problem and resolve it. Right.
Create a problem and resolve that problem.
The problem is created. How we can see
problem. If the problem is created, how to resolve the problem? Problem creation, it can be multiple ways, sir. Maybe sometimes worker node will go down. That can be a problem. Pods getting deleted. That can be a problem. Okay. So whatever the problem that is coming, that you can see here in the cluster, then we need to do the analysis on that part. Now see, I'm going for the pod count. Okay. So currently, how many pods are running? Data source, namespace, which pod that you want to see. AWS node pods are available, core DNS pods available, Q proxy. So from particular namespace, you want to see the pods. Okay. So I want to see the pods belongs to the Prometheus is the data source for me, and I want to see the pods of the default namespace. And in the default namespace, what all the pods available, I can monitor all those pods also. So you can see here when I go for the dashboard, there is the option to see the compute resource pod. Okay. So node pods, you can check it. You can select the data source from where you want to see the pods. From the default namespace, I want to check the pods. What is the node of which worker node pod you want to see? If you select both worker node pods will be displayed. Okay. So some pods are running on the first worker node, some pods are running on the second worker node. You can see those details also. So if you click on this particular pod, see currently there is nothing data available in this pod. Okay. What is the CPU usage in that pod? How the requests are coming to that pod? How it is responding? All that information will be tracked and can be monitored here.
Ashok sir,
yeah.
Can you run the stress command in the stress command in the yes.
Can you run
the stress command? That is the command that will overload the CPU.
Stress command. Yeah, if you want to, okay, you're talking about the HPA, right?
Yes.
Yeah, if you want to run the stress command, first you need to create one service, right?
Okay.
You got my point. Earlier, when we go for the HPA, we have executed the stress command. When we are executing the stress command, we need to give on which service you want to keep the stress.
Correct.
You understand? This is the command which is used to execute which is used to keep the load on the service. So if you want to keep a load on the service, you need to give that service name here. Okay, yeah. So we are able to access these pods. You can check the pods now. kubectl get service. What are the services available? There are several services are running. One service is Prometheus service and one service is Grafana service. Okay. Prometheus will use port number 9090 by default. I enabled that port number in the security group inbound rules and I'm able to access Prometheus dashboard.
Sir, I also work on this Grafana. They use this node exporter for me to create a report when I create. So do we install that outside or the Helm take care?
Helm will, whatever the software you want, Helm package will be available. You need to download that package and execute that package.
Okay. Because in my work, they basically download that node exporter again when I work.
Why node exporter?
They actually they want to monitor each node by traffic. So the black box they use something and they download that node exporter also for this Grafana.
Okay. Okay.
So when we
node
get into
exporter
the
nodes available here. Yes, you can see that. You can see node exporter nodes will be available. Node exporter nodes available.
Yeah.
What are the nodes available? So there are 2 worker nodes available. So data source is Prometheus. You can select the node public node IP. So this is the node. What is the CPU usage of the node? What is the average load? Okay, memory usage of that node. You can monitor these details by using node exporter. Here you can select the second worker node. You can see memory usage of the second worker node 21% available and first worker node 19% is available. So this is the node exporter means which will give you more information about your worker node. For each worker node, a separate graphical representation will be available based on the data that is used, based on the load that is there on the node. You can get it from here only. Node exporter option is available. So all the resources, guys, it's not like only nodes, only pods. What all the resources that are available in the Kubernetes cluster, everything can be monitored in the Grafana.
So the commands which you use to install all these, are they static or they change from?
Comment you can read anything, sir. Commands are standard. Okay.
So we can use them in our office if we want.
So these are commands to install the Helm. This is used to add the metric server to the Helm repository and install that metric server. That's done. Then coming to the monitoring purpose, Prometheus and Grafana. So we are adding stable repository to the Helm. Then we are adding Prometheus community. Then we are updating and we install Prometheus community first. So whenever you execute Prometheus community chat, it will install both Prometheus and Grafana pods. By default, those pods are exposed by using cluster IP service. So if it is a cluster IP service, I cannot access them outside. Okay, so to access them outside, I'm changing the service type to the load balancer. To access them outside, I'm changing it to the load balancer. So how we are changing the service type to the load balancer? Already we know the service name. Just we are using kubectl edit service name. So this service is created by using Helm chat. Helm chat means nothing but set of YMLs only. So whatever the YML that is used, whatever the YML that is used to create that service, it will come in the editable mode. There you can change the service type and you can get the load balancer as a service type. You can get the load balancer as a service type. Same thing we applied for Grafana also. Prometheus service type we change it to load balancer. Grafana service type also we change it to load balancer. Once we change them to load balancer, those services we are able to access here. So especially Grafana dashboard we are able to access, and when you access Grafana load balancer URL, Grafana will run on the HTTP port 80 only with the load balancer. Prometheus will run on the port number 9090. So 9090 enabled access to Prometheus dashboard. Then Grafana is using 80, so that is by default enabled in the security group in the cluster. So directly I'm accessing Grafana URL.
Hello, sir.
Yeah.
So in the YAML file for the Grafana, you say it's already made a YAML file. So how do we access that YAML file through net?
Can you come again?
You said the YAML file for the Grafana for the service is already made.
Yes.
Now, if we want to excluding the code you have given us now, if we want to access it in the internet to get that file, how do we go about it?
Yes, we have done edit, right? Whatever the YML file is there, those YML files are already available in the chat repository. So when you execute the chat, the YML files will be executed. You can't see those YML files. But when you click on edit, then that YML file will come in the editable mode. There you can modify and close that file. Then that file will be reapplied. You can't see that YAML. Only when you give edit command, then that YAML structure will be displayed for you. There you can do the edits. Now you see here, if you go and execute cluster ls-l. So just we have downloaded the Helm software sh file and we have executed that sh file. That's it. So these all are the YAMLs that we created previously. Let me remove all of them. Yeah. So currently my YAML files are not available. Okay, nothing is available. Now, when I execute this edit command for the Prometheus service type, you can see that service already running in the cluster. The name of the service is stable cube Prometheus stable Prometheus. So when I use kubectl edit service name, we are getting this YAML. From where we are getting this YAML? From the Helm chart. This is not our YAML. This is the YAML which is used by Helm to execute the service, to create the service.
Okay.
So this YAML is not created by me. This YAML we got when we execute edit command for that particular service. So how this service is created? Service is created by Helm chart. What is the meaning of Helm chart? Set of manifest files. So that means Helm people already created all these YAMLs which are required to install those softwares. So instead of we are writing those YAMLs again, we can just use the Helm chart and we can install that required software. That is the concept of package manager in the cluster.
Okay.
Sir, how do we get the required?
Sorry, how do we get the
required Helm chart?
Exactly.
Helm repository will be available, sir. Helm official website will be there. There you need to search for the charts that you want.
Sir, it is not keeping locally those environments.
No, sir, it will not be available in this local. Just chart will be available. Chart will be executed directly.
Okay.
Sir, can you show us once how to access the required Helm charts?
Yes. Helm repo.
So the YAML file which we created, that ns.yml like this we created, right, previously. So this also we can access to Helm chart.
Yes, you can access. So this is the Helm official website, guys. So here documentation will be available. Helm.sh is the website URL. There you can go to the chat section. Artifact hub is available. Search for the packages that you want. Suppose, for example, I want to go for metric server. So metric server Helm chart is available. So when you click on this metric server, so it will give you metric server, whatever that I have executed. This is the URL. I can compare this and I can show you. So this is already available in the official website of the Helm. So this is the Helm chart for the metric server. In our notes also I have given that. For the metric server, I used one Helm chart, right? Yes. Add metric server repository to the Helm. This is the command. Helm repo add metric server, Kubernetes size github.com metric server. Then after you have installed the repo, you can install the chart by using Helm upgrade. Same thing, Helm upgrade command. So what are the charts that you need? They are already available in the Helm official website. Okay. So you can go to the Helm website. There you can click on the charts. There you can search for the charts whatever you want. For example, you want a metric server. I have already shown you this. If you type metric server, it will give you the chart which is required for the metric server. Similarly, I want for the Prometheus. Okay. So when I go for this one, Prometheus. So the same thing, whatever this available in the official website, same thing I have added in our notes also. For the Prometheus and Grafana, what is the Helm chart I have taken? Prometheus community Helm charts available. So this is the Helm chart for the Prometheus. Helm repo update, which is used to update that Helm repo once it is there. Then we are going to install the chart by using Helm install stable. Prometheus community we have taken that chart we are going to install.
Yes, sir.
Yeah.
So is there any way we can do a demo in a situation where a mistake is made and now we can now rectify the mistake in the chart?
So charts are already predefined, sir. So if you want to delete that, whatever you have installed, you can delete it by using Helm delete, whatever the chart name you have used, you can delete and you can install once again. So here, if you are writing the YML files manually, there is a chance that you can do some mistake. But these YMLs, these charts are already tested, they are public, they are official. There is no chance of doing a mistake with that, right? You are executing the Helm chart, which is already given by the Helm people. How it will go wrong? They are already tested, then only they will release into the public, right? If you want, you can, whatever the Helm chart you have installed, you can delete that Helm chart from your cluster. That you can do it.
Sir, can't we just cut down the pods to just see the problem in the, can't we see the down in the pods or nodes to see the problem in the Grafana?
Sir, Grafana will not show you what is the problem in the pod. It is going to show you what are the resources available, what is the CPU utilization, how much memory they are occupying. That information you can get in the Grafana. If the pod is down, that will not come in the Grafana, right?
There will be auto scaling, I guess.
Suppose here if you go to the computer research pods, what all the pods are running, the pods information, what all the pods are running, the pods information it will show you. If you delete one particular pod, that will not be available here. No? It is used to show you, the Grafana will show you the memory level details, how much they are consuming, how much load is there, what is the CPU utilization on that. Suppose if the pod is crashed, then you need to see the pod logs. To see application is down means if there is a problem in the application, that problem you can see in the log files of the application. Log files you can monitor by using EFK, that is different. So Kubernetes cluster monitoring is different, application logs monitoring is different. For the cluster monitoring, Prometheus Grafana we are using. For logs monitoring, EFK stack we are going to use. Both two types of monitoring is required here. One is cluster resources monitoring. Second one is application logs monitoring. Are you getting my point?
Yes, sir. Sir, I have
to get alerts from this update from the resources changes to get alerts.
Right. Alerts we are going to get. You can configure the alerts. Alerts manager can be configured in the Prometheus.
Sir,
application logs means whatever the
execution process. I have given the task on the Friday, the same thing. Application execution process will be stored in the log file. Those logs we can monitor by using Kibana.
Okay, miss. Whatever the wrong going on in the whatever the
Application,
website.
something going wrong in the application, that will not come in the Grafana. That will go to the log file.
Okay. So in the ELK, we can find whatever going in the whatever
Yes, whatever
wrong
is
in
going
the
wrong in the
application.
application, we can find that in the ELK.
Okay.
Whatever is going
So,
wrong in the cluster, that means any worker node load is there, CPU utilization is going high in the worker node, those things can be checked in the Grafana.
okay, yeah, got it.
Sir, one question. Sir, when we edit the YAML file which is there in the help, so while editing, if we do any mistake, like mistakenly we do editing, means where we can see that that will be a
Whenever
problem
you
or not?
edit, whenever you do some mistake in the YML file, right? So when you edit this file and when you save that file, it will give you the error. For example, here my cluster is running. I will go here and I will click on edit that service, whatever is there. The same previous command. kubectl edit service type is there. This is a predefined service we created by using Helm chart. I'm editing this service now. I will do some mistake in the edit process. Okay, load balancer is available as a service type. I'm giving some wrong service type name. Service type I'm giving wrong. I'm giving load balancers. It's a mistake, right? Try to save this. It is not getting saved because there is a problem. It is not accepting that. So I'm trying to save it. Come to the escape mode. Service type I have given as wrong. Okay. Escape colon WQ. So I'm typing colon WQ. What is the meaning of colon WQ? Save the file and close that file. Okay. When you save and close the file, if the file is correct, that will be applied. That file will be re-executed. But in our scenario, when I try to save and close the file, now you see edit cancelled. No valid changes were saved. But because boss, whatever you are doing, that is a mistake. That is invalid. The service that you are trying to do is invalid. Your changes stored to one temporary file, the real service is not modified. If you give the valid changes in that service by ML when you are editing, then only it will accept. As I have given the type name as wrong, it is not accepting my change. Now let me edit this again with valid change now. Okay, service type is not modified. Even though we are trying to give some wrong name, it is not accepting it.
So how we will understand that there we have done the mistake? Means if we don't understand that YML problem.
Madam, Kubernetes means understanding the YML. I am telling you from the day one onwards. Kubernetes means you need to understand the YML. If you don't understand the YML, then how can you work with the Kubernetes? Why we are spending these many days for the Kubernetes? Yeah, your main duty is working with the Kubernetes means working with the YML files only, right? If you can't understand that YML, then how can you work with the Kubernetes?
Is there validation tools is there for YML?
No. These all are predefined keys and predefined names, right?
So one question here. So let's say we change the port number, node port number, and then also the 9090 is the default one. We change it to 9091, and a lot of changes I have made by myself, right? And if I want to go back to the default YAML that the Helm chart
So
will
if you
give
made
me,
the changes, if you apply that service, right, you can't do
right?
undo here. Again, you need to delete the chat that you have
Delete.
installed and you need to reinstall the chat.
Okay. That was the question, I guess. Like,
Yeah.
yeah. We need to delete that, and then when we reinstall it, it will
Yes,
give us the
it
default.
will go with the default values. When you reinstall it, it will go with the default values.
Again, the type will be not load balancer.
Cluster IP.
It's
Cluster
IP. Yeah.
The default service type is cluster IP. So if you delete this, whatever the chat that you installed by using Helm, if you delete and reinstall, again it will go with the fresh installation. It will consider as a fresh installation.
So if we save the file 2 times, then also it is having the default changes, no sir?
Yes.
Sir, so whatever changes we make in the YML file, it is getting stored in the chat. So it is
Sir, it
now
will
local.
update the chat, sir. It will update the service.
Yeah, which is in the local system, right? The
Right,
chats
right.
that we
Not in the chat repository, it will not update. Only in our cluster, it will be updated. It will not affect for everyone who is using the same chat.
yeah,
No.
but
Sir, in
Sir,
graph,
I have a question regarding, sir, one rare scenario. The pods are running perfectly all right. So can we manually, create a problem to the pods?
The only way to create the problem to the pod is delete the pod.
Okay.
Or else your pods are running and your pod is connecting with the database. If you down your database, then pod will fail.
Okay.
You got my point. Inside the pod, application is running. Application is connecting with the database. If you delete the database pod, then application pod will fail.
Okay.
So does Helm work with Kubernetes native resource with because things like Grafana, Prometheus, those are external to Kubernetes, and I want to know if like horizontal to HPA are internal to their Kubernetes defined things. So can Helm easily do the things that are from the Kubernetes native resources? I don't know if my question is clear.
Sir, Grafana Prometheus, not only in the Kubernetes cluster, they can also use it to monitor the native servers also. You can use them.
One final understanding is these Grafana and the Prometheus, these are used to monitor the CPU, memory,
Yes,
and the
cluster
pod
resources.
status.
Cluster resources you can monitor.
That's it. We cannot
application
monitor.
level monitoring, no.
Okay.
Application logs monitoring, different EFK platform. I have given the EFK video also for you people to do the practice. How to check the logs of the application.
Yes.
You people did not try that. That's why you are having a lot of questions.
sir, in Grafana server, when any folder is deleted, how can we retrieve it, sir?
Folder deletion. What folder you will delete in the Grafana, man? It is a service you are installing by using Helm chat, right? How do you delete a folder? You can't delete anything. It's a service that you are getting with the Helm chat.
Sir, one question, sir. So the YAML file which you deleted, right? That namespace YAML file which we created in our local system. So this also we can access through Helm chart.
I did not get your question. Can you come again?
So the just now you deleted all the YAML file, right, in your system.
Yes.
So these also can be accessed to Helm chart.
That means those YML files I have created manually and I have deleted those YMLs.
Yes.
Okay, those YMLs will not be available in the Helm charts, right? If you want, for our application, we can create our own Helm chart and we can deploy our application by using our Helm chart. That you can do it. So currently, whatever the YMLs I have deleted, those are my local files. Helm don't know about my YML files. No? You know my point.
So in real time, is this happen like this thing?
Sorry?
Like creating the YML file and uploading in the Helm chart, like.
So your voice is breaking for me.
I am saying, like you told, like creating the YML file, and we can upload in the Helm chart and we can use it. So
Yeah,
is
some
this
people, there are multiple ways to do this deployment, sir. Some people will deploy the application in the cluster by writing the manifest YMLs. Manually, they will write the YMLs and using those YMLs, they will deploy the application. In some projects, for our application YMLs also, they will create a Helm chart. I will show you how to deploy our application by using Helm chart. Tomorrow we'll work on that part.
Sir,
how to create our own Helm chart. That is the concept basically.
Sir,
how
is
can I
Helm
change
chart
the-
now? Is Helm chart not available to create the resources?
I'm not getting your question. Speak loudly.
Sir, is Helm chart not available to create the resources?
Is a Helm chart not available to create the resources? What resources you want to create?
For example, pods we want to create, or service we want to create, or
you need to you need to create your own Helm chart for that, because the pods and services are belongs to your application, right? How Helm will know about your application?
Oh, okay. Right. Perfect, sir.
So these are the public resources. These are the resources. These Prometheus, Grafana, metric server, these are common for everyone. So that's why Helm charts are available to install those softwares. Now, to deploy your application by using Helm chart, you need to create your own Helm chart for that. Helm people will not know about your application, right? Okay. So
yes.
Just I want you people to practice this Prometheus, Grafana, metric server setup by using Helm. Tomorrow we will discuss how to deploy our application by using our own Helm chart. How to create our own Helm chart in order to deploy our application, that we will discuss in the tomorrow session. Okay.
Today's class is very interesting, sir. Thank you.
Thank you, guys. Thank you. So today we discussed about what is Helm, okay, and how to install the Helm in the Kubernetes cluster, and how to install the metric server in the Kubernetes cluster by using Helm chart. And we discussed about how to deploy Prometheus and Grafana by using Helm chart, and how to access Prometheus and Grafana URLs to monitor the Kubernetes resources we discussed. In the tomorrow session, I will show you how to create our own Helm chart to deploy our application. That means in the interview, they will ask you, can you set up your application deployment by using a Helm chart? That means you should create your own Helm chart. So as of now, I used Prometheus, Grafana Helm chart. I used metric server Helm chart. But those are public Helm charts. They are already available. Anyone can access to install those softwares in the cluster. But what about my application Helm chart? My application means it's my responsibility, right? We should create our own Helm chart. In the tomorrow session, we will see how to create our own Helm chart to deploy our application. Custom Helm charts, the topic that we are going to discuss tomorrow.
Thank you very much.
Thank you, guys. Thank you so much. I will update these notes and please do the practice.
Sir, one
We'll
question.
continue tomorrow.
Hello, sir.
Yes.
Can we deploy the EFK stack using the Helm chart?
Yes, EFK stack we can deploy by using Helm chart also, because EFK stack is also famous in the market, right? So everybody will use EFK stack.
Yeah, actually, I was searching for the repository. It's showing me the repository.
Yeah, in the repository you can find out that. So in the video, I have used normal YML files to deploy the EFK. You can set up the EFK by using Helm chart also.
Okay.
Good. Thank you, guys.